In part 1 of this series, I shared this working definition of number sense and this list of hallmarks that activities must have in order to develop or foster number sense. And they must provide open input. They must foster multiple models for number. They should involve estimations, approximations, and judgments of reasonableness. And they need to establish connections and relationships between numbers and operations. They need to support mental computation strategies, promote creative thought and logical reasoning, and last but not least, they need to encourage students' language, discourse, and personal thinking. In this episode, we're going to explore activities that provide open input. Now, what do I mean by open input? These activities usually require students to use randomly generated numbers, or they allow students to make their own decisions about the numbers in operations. In other words, the students aren't locked into one fixed pathway. They need to think, decide, and justify their moves based on reasoning rather than one fixed procedure. I'll start by sharing one of my favorite games. And I really like this game because the numbers are generated randomly, but also because it really makes students think. In fact, I've done this with a lot of teachers over the years as well, and they find it challenging. The other reason why I like it is it provides a template for teachers, which they can take to create other games for students of various abilities. Let's take a look. You can see this is a game for 3 players, and there are 6 rounds to play. Players take turns rolling 3 standard dice. After rolling, the player must decide where to place those 3 digits in their first equation with any operation they want to make a total that is as close to 50 as possible. For example, a student who rolls this might write 53 subtract 1, which is 2 away from 50. They could also write 51 take away 3, which is again 2 away from 50. 15 times 3 is 45, so that isn't any closer. So for now, we'll just keep our first answer. Then player 2 has a roll, and if they roll this, they could write 42 plus 6, which is pretty close. And the third player might roll 1, 3, and 3, which means the closest they can get is 39. After each round, the player with the score closest to 50 gets a point. In this example here, 2 players have a result that is 2 away from 50, so they can share a point or have 1 point each. And the person with the greatest score after 6 rounds wins the game. And I really like it. As I said, I've seen children play it and they really enjoy the challenge. But let's take another look at this game. Again, consider it to be a template for other games. Suppose I have very young students. I could remove the third digit and give them 3 cubes from which they can choose 2 to make an odd or an even number. If they have learned their multiplication facts, I could leave 2 single-digit spaces and give them 3 cubes from which they can choose 2 to make a total close to 20. For older students, you can go back to your 3-digit spaces and add a decimal point like this. In this game, they could use any operation they like to make a total close to 10. Or you could separate the 3 spaces and add another operation circle like this. This will bring in order of operations and is very interesting when the target number is kept low, like 10. If you look carefully, you'll find many games that require open input. I'm also a big fan of target games because you can physically play them with the students, and you can easily change the game by simply changing the numbers or the number of numbers. Let's take a look at one. Imagine you throw 3 beanbags at this target and you added 3 numbers to get a total score. If all the bags hit the target, What is the lowest number I could get? I figure that is 15. What is the greatest number I could get? Mia thinks she can make 30 at least 3 ways. Is she right? I could see 3 10s make 30, a 5, a 10 and a 15 make 30, and a 20 and 2 5s make 30. So I guess she's right. What other numbers can you get? I can see I can get 50 by adding 2 20s and a 10. I can also get 45 by getting 3 15s. Can I get 32? Why or why not? Well, the number needs to end with a 0 or 5. One boy once said you can get every number that ends in 5 and 0, starting with 15 and finishing at 60, and I'll prove it. Let's take a look at his reasoning. He said if you put 3 beanbags here, that's 15. If I move one to the right, that's 20. The second one to the right is 25, and the third one over to the right is 30. If I move one down to the 15, that's 35. The second one down to the 15 makes 40, and the third one down there makes 45. If I move one over to the right, that makes 50, the second one makes 55, and the third one makes 60, and he said that's all of them. And he said it about as fast as that. You can also use 2 targets to involve both addition and subtraction. Let's take a look. If you threw one dart into each of these targets and you added or subtracted your 2 numbers, what answers could you get? For example, if I hit 40 on the left and 70 on the right, that could give me 110 if I add the 2 numbers. Or I would get 30 if I find the difference of the 2. So with that in mind, can you get an answer of 120? How? Well, I can't add a number from each target to make 120, I can see that. And I can tell you that no 2 numbers have a difference of 120, so I guess no, I can't get an answer of 120. Can you get 50? If so, how? Well, yes, 20 and 30 make 50, as do 40 and 10. And I can see pairs of numbers that have a difference of 50. Can you get 40? Why or why not? I don't think so, as both darts would need to land in the target on the right, and the rules don't allow for that. And you can finish the activity by having the students find all the numbers they can make and tell you something special about those numbers. The last game I want to share combines open input with place value reasoning, and it's a great game to get the students thinking strategically about place value. Now, all you need are 10 cards, 0 through 9. I'm going to use a joker as a 0 and the ace becomes 1. As a teacher, I randomly draw a card and the students have to place that digit with the aim of making the greatest 4 digit they can. Now if you look down here, you'll see these are the results of 3 imaginary students. 2 of the students decide to place the 7 in the thousands place. 1 student decides to place it in the hundreds place, as there are still 2 digits greater than 7 yet to be drawn, and there are still 3 more draws. Now I might next draw 1, and that makes the decision pretty easy. I suspect all students are going to put the 1 in the least place, or the smallest place, and that is the ones place. The next one is a 5. Now that's a little bit more challenging because it's like a midway number between 0 and 9. Where do I want to put that number? Where would you place it? At this stage, I really like the chances of player 1 to win, but let's see what happens. It's an 8. So this is how the first round ends. And you can ask yourself, which is the greatest number? And you can see that player 2 wins. But as you play the whole class, you have many more numbers to choose from. So be sure to ask who has the greatest number possible. And in this example, you can see that actually player 2 also had the greatest number possible. But don't stop there. Continue by saying, what is the next greatest number? And the next greatest number again. And from years' experience, you'll find this is very challenging for students. And again, in my professional learning sessions, even teachers sometimes find that quite challenging. So this is what I want you to do. 1, look for activities that allow open input. And as I said before, those are activities that require students to use randomly generated numbers or have the students look or make their own choices based on the numbers or operations. And 2, use the game I've given you in the link. And if it doesn't suit your student's age group, by all means use it as a template and create new games in the ways that I discuss with you. And finally, if you've seen value in this episode, please give me a thumbs up, share it, and subscribe today so you never miss another learning opportunity with me. See you next time.